Isso é o meu filho que é maluco. Minecraft. É, por acaso, jogo por jogo, eu até prefiro que ele jogue esse do que jogue outros.
Pois.
É.
Agora termina.
O aplicativo de instalo terminei. Se o aplicativo de instalo terminei.
Ah, sim. Não dizer que
Sabe uma história do seu British accent, sabe qual é? British accent. Eu falo inglês, falo British. Eu acho que não. O British é que fala americano. Claro que sim. Depois, mas não, mas fala British. Então, nós tínhamos um projeto europeu que tinha aí 5 universidades ou 6 diferentes, e uma altura muito toda, iranianos, chineses, e toda a gente falava inglês. A gente falava assim inglês mais ou menos macarrónico, não é? E sabe, a única pessoa que ninguém percebia era o British. Ele falava e ninguém percebia nada que ele dizia.
eu acho que tem isso.
Hein? Eu noto. Não, não está mal nem bem, é só engraçado. Porque realmente os verdadeiros ingleses, quando falam, ninguém os percebe. Então, Crash Course de Terminator, é isso que você quer? Então, liga lá, partilha lá o seu ecrã. Okay, então, so we switched to English because of Egino. So to learn about Terminator, well, the shortcuts are Control Shift and then some keys. Always Control Shift, in order to not interfere with other system shortcuts. So if you want to, for example, divide horizontally, you do Control Shift E. And for example, if you want to close, you do the Control Shift W. Now, if you do Control Shift O, it splits horizontally, and now if you do Control Shift E, it splits this part vertically. Now you can go from one terminal to the other. The one that has the focus now is the one in red, by doing Control Shift Tab. Okay. Oh, I think if you do Control Tab, you will move on the other direction. Yeah, Control Tab as well.
Okay.
Control Tab, and well, that's it. I don't think you need a lot more. There are many other shortcuts, but these are the ones I use mostly. Well, you can do Control Shift E. Yeah, Control Shift W again. And now you can also do Control Shift up down key arrows. Yeah, and then if you go, for example, to the second terminal and you do Control Shift to the left, yeah, so you can resize them. Yeah, this is nice. Terminator. No problem. So let's get started because we have a lot to discuss today. So I will start from the last class onward. Okay, so let's first get to the point where we were in last class. That would be P22B part 08 blah blah blah. So I'm talking about PSR. Let me just go there. Part 8, and we are talking about this one. Well, not this one, this exercise 4. Where is it? Here. So we are doing serialization and deserialization in ROS, and we were able to figure out that this is working perfectly. So now we are jumping into exercise 5. Okay. So what I will do is I will create a new ROS package and copy everything that is in exercise 4 into this new ROS package. So again, to create a ROS package, I have to go to the proper place. So I go into part 08. Let me just copy this path. And then I go CD paste. Now here I'm going to create a ROS package. So catkin underscore create package. The name of my package, that would be PSR 22 P2. That's the name of this class. Actually, I did P2 the other, yeah, I did P2 in P1. So I'm going to call this P1. Part 08, exercise 5, okay? So that's going to be the name of my package. I know it's a complex name, that's just because I need to create this package over and over again to explain in different classes. In your case, you can just use what's suggested in the PDF, that's fine. Now, primary dependencies, ROS CPP, ROS PI, STD, MSGS, okay, standard messages, and that's it for creating a package. So after you run this, you have created a new ROS package, which is here. You see here, the one in green. That's the part PSR 22P1. That's the package that we are working on right now. Again, we do not need this include. We don't need this include. And now what I'm going to do is I'm going to copy exactly what we had in exercise 4 directly here. So it means that we are also going to have a message definition in this exercise 5. Okay, copy here. I need to delete the source folder and to rename this one to SRC. So now we have here a message, doc message. We have our publisher and subscriber. Here you go. This is the publisher, this is the subscriber. And if you take a look at the imports, we are actually using the dog message, which is defined in the exercise 4. That's not what we want. We want to use this particular dog message. So let's just make sure this is the correct shortcut. So PSR 22P1 part 08 exercise 5. That's it. Okay. So let me just put this here. Hello. Now, what do we need to do extra? Remember that in order for us to use this dog message, which we had defined in exercise 4, we had to do some stuff in this package.xml and in the CMakeList.txt. Those were done in the CMakeList and package.xml of exercise 4. So that means that exercise 5 has the CMakeList and the package in their original format, therefore not having the compilation of the message configured. So we have to do it again, what we did here for the tutorial of creation of messages, in this case for exercise 5. So the message, it's already defined, we copy the file, it's this file here, doc message. Now we have to uncomment the build depend and the exec depend for the message generation and the message runtime. That's what I'm going to do now. I'm going to my package XML message generation, message runtime. That's it. Now, next, we have to go into our CMakeList and add message generation to the Catkin required components. So let's open the CMakeList. I'm just repeating what I did in the theoretical class. Message generation here, right? That's it. Next, we are going to add in the Catkin depends the message runtime. So Catkin depends. We are going to add Catkin depends. Yeah, here. We are going to add here the message runtime. Okay. Next step. We are going to add our message files. So that's finding the add message here, uncommenting it, and our file name, our message file name is called dog.msg. So that's it. Finally, yeah, that's it. Now we have to do this generate messages, uncomment the generate messages part. Generate messages is here. Okay, uncommented. And I think that's it. Okay, then I'm just doing whatever is here. So generate message is already done. Then we have to compile. That's it. Now, in order to compile, we have to go into our Catkin workspace. So in my case, it's called cd Catkin ws PSR, and I do Catkin make. This is to compile. The compilation involves compiling any C++ code, which I do not have. I just have Python code, and then compiling the messages. So you see here that it's generating the messages. So this is although it's the same, has the same exact fields, it's a different message because this is the dog message for the ROS package EX5, and the one we did this morning was the dog message from the ROS package EX4. Now that we have this message, we can actually run our publisher and subscriber in exercise 5. Let's try it, okay? So, if the first thing we do whenever we create a new package, which we have done, is to see if this package is being found in the ROS ecosystem. So let's try the ROS CD PSR 22 P1, that's the name. So it's not found. So we have to ROS pack profile. That means we have to update the list of ROS packages. ROS CD, again, I tried like PSR 22 P1. Okay, so now I have exercise 5. Okay. From the moment that I have this exercise, now I can run my nodes either by going into the source and then doing /publisher, or even better, I can do ROS run, and this command ROS run will require the package name. So the package name is PSR 22 P1. This is the package name, and then I'm going to call the publisher. If I run this, it says that there is no master node, so I have to run ROS core. But now it's working. It's working like we had before. So we are now publishing a dog in this publisher.py. We can also do ROS run PSR 22 P1. That's the name, exercise 5. And we can also do the subscriber. Okay, and now we have one node talking to the other. That all this was just to have the exercise from this morning in a new ROS package, okay, which now is called exercise 5. Now we go into the real juice, which is the following. We want to do a new service. So we want to be able to change the name of the dog as the publisher is running. So the publisher is always running with the Lila. I told you, Enrique, this is not a good name, so we're going to change the name of the dog, okay? So we have to change the name of the dog, and we do that by making the publisher node not only a publisher node, but in addition to that, a server node. So it's going to it's going to serve a service, which is the service to change the dog's name. Now we have to do several stuff. The first thing we have to do is to define the service that will set the dog name. So we have to do a new service. Again, we have to follow the tutorials. So this tutorial for the creation of messages also has a tutorial for the creation of services. So here, creating a service. What we have to do is to create a folder called SRV, which will contain our services. So in our package, we are going to create a folder called SRV. Then inside the folder called SRV, we are going to create a new file called set.dog_name.srv, a new service. And how do you define the service? What is the syntax? Well, it's exactly the same as the syntax of the messages. So you just have to define something like, let me go, where is it? Something like this. So this is an example of a service. Now, the difference here from the messages is that we have these 3 dashes. What are these 3 dashes? When you are sending a message, you are doing that in a publish, subscribe paradigm. What does it mean? It means that, just a moment. It means that if you are, for example, if you have a particular node A, you are going to be sending messages to any node that's listening B. And you send one message, then you send another, then you send another. Then if C connects also there, when you send a 4th message, you will send it there, and so on and so forth. But that means A is talking, and B and C are listening. And therefore, the communication is unidirectional. It only goes from A to B and C, never from B and C to A. Okay, and this is the paradigm publish, subscribe. Sometimes, as is the example of the set dog name, we want to do a different kind of paradigm in the sense that we also have a node A, which is publishing stuff, that is publishing the dogs, okay? And the dogs have a particular name, which is the Lila. The legal, okay. Now, this is happening periodically. Now, I want to be able to send a service, which will be set dog name. This set dog name must have a response. So that's the difference in the paradigm. I'm not just sending a message, change the dog name. I'm saying, please change the dog name. I need a response saying something like, okay, I was able to change. So when we are using the paradigm server client, the communication is bidirectional. Why? Because you send a request, and this is from your client, and this node is a publisher but also a server. And the server, when the server receives a request, it will respond with, in this case, a set dog name response. Okay, so the communication using the server client paradigm is bidirectional. The server is the one that doesn't not have initiative, is just waiting. Whenever the server receives a request, it responds with a response. That's it. But that's different, fundamentally different from the publish subscribe paradigm, which I draw in blue. Okay. So this to say that if you see how this works, you see that for me to be able to establish a service, I need a request and I need a response. I need to define both of these. And these two are here. Oh, sorry, are here. So that's what the 3 dots mean. They mean that whatever is above the 3 dots is the request. And whatever is below the 3 dots is the message containing the response. Okay? That's what we are doing here. We are defining the request and response format. Now, in the particular case of the set dog name, what can we do in this SRV file? Well, in order to set the dog name, we will need a string to define what is the new name of the dog. So let's define here a string, new name. Okay, then I don't think we need anything else. We just say, okay, that's the new name. Then we go into the response, and the response is actually even simpler because there is really nothing to do in the response. The only thing that I would like to know is if the new name has been successfully attributed to the dog or not. So let's say that we have a Boolean, which is the result. Okay, yes or no. So that's our service definition, nothing special. Now that we have defined the service, we can go here into the service. Where is it? Yeah, here. Now that we have defined a service, we have to do also the configuration of the service. So first we declare the SRV folder, then we create the file, then we have to add the message generation, the message runtime. We've done it already, no need to do it. Then we have to add the message generation to the find package. We've done it already, no need to do it. Then we need to add the service file. That part we didn't do yet. So let's do it. So we go again into the CMake lists and we search for this add service files. And we have our service file, which is called setDogName.srv. Okay. Okay, then I think that's it. Then, of course, what you need to do is to compile. So again, we will need to recompile because we have a new service definition that needs, again, to be compiled to the different languages ROS supports. So let's do the compilation. cd catkin PSR, catkin make. So if all goes well, it will create the service. You can read here that it's creating the service. Here, look, it's creating, for example, C++ code for the service setDogName.srv. That's it. So now that means that I have my service well configured, all I need to do now is to expand the publisher node to make it not only a publish, but also a service node. So actually, to be more clear, I will stop calling it publisher. I will start calling it publisher service. Okay, because it does two things at once. So this publisher service will not only be able to publish periodically, that's what it's doing now, but it will also be able to service the new service we've created. How? Well, we have to look at the tutorials for the creation of servers and clients. Here it is. So you just go into the place where we have the simple service creation. Here's the code. So I'm just copying whatever is interesting from here. So, well, actually, rather than copying it myself, I will ask you, what do you think we need to copy to the other side from here? Please louder, Henrique.
Is the print function necessary?
The print?
I don't know.
Which print? There are two prints.
No, the from feature import print function.
No, no,
It's
no.
not.
Well, don't focus on what's not important. Focus on what you think is important. Prospect pod service. Okay, I agree with Miguel. So this code was creating a service. Where is it really creating a service? Here. That's the most, of course, we need more, but that's the key component, prospect.service, of course. So let's copy, paste, and adapt. So we are going to create this during our initialization. For example, after we create the publisher, we are going to create the service, sorry. Create the service, right? Now, we are going to have here service. I like the names differently. So now here, what is going to be the name of our service? That's the same as the name of our topic. So servers are also on topics. In this case, the service is often called the name of the service, but in snake case, like this, set dog name, okay? So remember, the service was set dog name. I just changed it to snake case, set dog name. Now, here it's asking, what service am I supposed to serve? What is the type of the service? Here was a... It's just a convention. What did I say? What was said? Eu não percebo o seu inglês, meu, é impressionante. Desculpe, mas a culpa é minha, mas... Normalmente usa-se o camel case para definir tipos. Por exemplo, classes. Eu não defini, mas ele já está definido quando ele compilou o serviço. Portanto, o nome da mensagem do serviço é setDogName.srv. Portanto, ele vai criar uma classe setDogName com capitals no S, camel case, ok? Tipicamente, a lógica é sempre tipos e estruturas mais abstratas de alto nível, abstratas, ficam com camel case, e depois quando são instanciações, snake case, está com mais variáveis, não é? Ok. So set dog name. Now we need to define here our service. And of course, like Roberto was saying, we don't know it yet. So we have to import it. Look, here we did before. From PSR 22 blah 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 exercise 5, import from the SRV folder our set dog name. You see? So now we can say that we are going to service a service. We are going to be the server of a service called set dog name. When a request is received, we have to do something in order to respond to such request. And we do that by defining a callback like we have here. Okay? So this is the callback. They called it handle to ints. For example, for functions, I don't follow the ROS convention. I use, it's not camel case because the first one is not capital. I don't know how to call it. So let's define this one. So this function here, I'm going to call it service request callback. And let's define it above. On line 10, go, paste, def. So it will receive a request and we must do something, okay? So that's our callback. This is where the code happens when a request for setting the dog name is received. So for now, we are just going to do something very simple, which is to print the received request for set dog name to, and we even put here the dog name. So that will be the request. And remember, the request was, the upper part, and it has a field called new name. So I can do request dot new name. Sorry, wrong parentheses, right? Okay, so that's it. I just printed, and I need to do more than that. Now I must respond to the service. How so? Well, I must create an instance of a response and then fill it and return that in the function. So how do I create an instance? When I compiled my service, I not only created this class, but I created another one called set dog name response. So I can just create an instance of this. So again, Roberto, this will be, for example, the response in snake case, and the class is this one, right? In camel case. So I'm just instantiating a response. And now, what do I have in my response? Only the field result. So I do response dot result equals 1. It's always going to work. Or rather, right now it's failing. So let's, well, that should be on the bottom. Right now it's failing, so let's put a 0 for failing. And finally, we need to return our response. What's happening with mine? Ok? É capaz, é por isso é que ele está a passar. Tem razão. É que ele está a passar. Obrigado. Okay, so respond to the service is a matter of creating a response instance, then filling it up, and then returning it. Right now, this code doesn't really change the name of the dog, but it does everything it needs to respond to the service, even if it is to say, I cannot set the name of the dog, okay? So let's try to run this service, to run this code. So this is the raw score. Now, how can we do it? Again, we launch here the publisher, which now is not called publisher, it's called publisher service. It's up and running. It's sending the dog name over and over again. And we can also launch on the right-hand side our subscriber. It's receiving the dog name over and over again. Now, we create here a new terminal on the bottom. And in this new terminal, what we can do is we are going to call the service directly from the terminal. So that's something new from what you said. But for example, all ROS functions, well, not all, but many are supported not only as an API, that means something that you can include in your own code, but also through the terminal line, through the terminal. For example, right now, I've created the code for the subscriber.py, and I'm running this code. This code is here on the right. You can see what it does. It just subscribed to the topic and printed it. However, I could have subscribed to this topic and print it through the command line. So ROS already implements a node, which is very similar, which is ROS topic echo. So echo means print a topic, which in this case is, what was the topic? It was, I forgot. Well, I can easily RQT, no, not this, come on. RQT graph. So I can easily see from here, oh, it was shattered, okay? Sim, podia ser ROS topic list também. ROS topic echo, shatter. So this node here, this is a node in ROS that only listens or subscribes to a topic and prints it to the terminal. So that's like a shortcut. You can use it in the terminal as well. Of course, now I have two subscribers of the shatter. The one from my code, that's the subscriber, and then the one from the ROS topic command. Okay. This to say that I can either create nodes that are done in my own Python code, or I can actually use these ROS commands to do some kind of debugging. That's what I'm going to do now. I'm not going to create a Python code for doing the ROS service client. I would know how, because we have here how to do it, but I'm actually going to call the service through the terminal. How can I do it? I can do it like this. ROS service call, and now I have to declare which is the name of the service. In this case, I have here my options, and I know it's the set dog name service. Now, when I'm here, if I push tab again, it will automatically fill my service request. My service request contains only the new name as a field. That's why it says there new name. That's it. If I would be trying to call a different service, for example, I'm going to call this one, ROS out set log level. Okay. When I press tab, it says, oh, this service contains in the request two fields, the logger and the level. Tell me which one they are. Okay, so this does an auto-filling. Okay, so we go back to the set dog name, and now I'm just going to say that the new name is Bobby. Or do you want to know? Yeah, Bobby. And now if I run this, look at what happens. This guy here said, receive the request for set dog name to Bobby. So it worked. Although the request failed, it says here, result false, didn't work. But the whole mechanics of one node asking some information from the other, that everything else worked, okay? So what do we need next? Well, now we go back to the code for the server, and we need to somehow add here a part. Well, yeah, the problem is my tabs. Actually, sorry, again. Okay, now yes. Now I need to add here a part where I will change the dog's name. So this is missing. That's why the name of the dog is not changing. In fact, you can see that the server, although I said change the name to Bobby, continued to say the Lila, and all the others receiving the Lila. So how do I change the dog's name? Who can tell me? Suggestions.
I suppose we are intercepting the message. Intercepting in the sense that we received from the message file the classes to replace the dog part of the file before we publish it.
Not sure I follow your reasoning. Let me ask you a different question. Where is the dog name that we are publishing?
Down there.
Well, I don't know what down there means. Line.
Where it's line 35.
Right. So it's in a variable called dog, which has a field called name. So that's what we need to change.
Yeah.
How?
We assign the Lila to a variable, and then we replace the variable in the.
Okay, so you want to do here a variable, what? Can I call it dog name? Variable. That's what you want? And here I put dog name, that's what you want?
Probably, yeah.
Okay, and now, well, but how? I still need to change this variable, right? How?
So up there,
Up there, I don't know what up there means, 15, right?
Right, dog underscore name equals the request document.
Okay. Thanks, Enrique. So, everyone agrees? No? Why not? Sorry, it's my fault. I am not. Right. Now I get it. Of course, you wouldn't be able to access the dog name. No, you wouldn't be able to access because it only exists. Well, actually, you would. It wouldn't crash, but this is what's happening. This dog name here, the variable on 35, is a variable that belongs to the main, and the variable dog name on 15 is a new variable dog name that belongs to the service. So these are two different variables with the same name. So how can you do it? Roberto, how would you do it?
I'm not sure.
Okay. Well, the problem is that you're not the one. That means your code is not the one that is calling the callback. It's being called automatically when a service is called. So you can't do that. Any other suggestions? Come on, we've done this before. Global variable. Yeah, sure. Sure. Let's do global variable. So if this is outside a function, that means it's global. And now we can say, whenever I say dog name, I mean global dog name. Okay. And I also have to do it here because I use dog name in both. Yeah, I can do that. And
Is having to specify inside the function.
Necessary. Well, I'm not sure about I'm never on the top of the wave in terms of versions because I don't think that's smart because you are always losing time just with debugging the new versions. So I'm not sure about 3.9, something like that.
Is it those things like that? Defining firewalls.
You do if you want to write on it. If you want to read from it, you don't. But I do it for explicit, for the purpose of having it as more explicit as possible. I do it anyway. Either I'm writing or reading. But look at what happens. If I don't do this here, and I write on my variable, I'm writing because I'm saying dog name equals something, it will not know whether it wants me to, whether I'm intending to write something on the global dog name, or if I'm wanting to create a local dog name variable and writing that there. So there is redundancy, and because there is redundancy, here you are obliged, it's mandatory that you do this. When you are reading from the variable, for example, no, if it was a list, it's the same, I think. Yeah, even though you would have to specify. I can do it. Well, let's do the parentheses for Roberto. Roberto.py. Not sure. I don't think so, but let's try it, okay? Horse CD, sorry, let's go there first. Cross CD, PSR 22 P1, yeah, source. Okay, so chmod, Roberto. Okay, now yes, so we can just run your code like this. Okay, now if I have a function def func1, which will contain no arguments, and I have a function def func2, which will contain also no arguments. Let's just simplify. This function will do a equals 7, b equals 6, something like that, and this function will do c equals 4. Those are just variables for the functions. And now I want to have a global variable here, which I will call g, or global var. So this global variable of mine, which is equal to 5, can be either read or written. If I do this, if I read from global var, this function will have no chance but to, for example, if I say c or d equals c plus global var, there is no redundancy here. So there is only one option, which is, well, global var does not exist in the local scope of function func1, so it has to use the global one. For writing, for example, so in this case, it works either way, but this global var is optional. Okay, so it works either with that or without. Now, if I want to write global var equals 3 or equals A plus B, for example, in that case, you must really specify, because if you don't do anything, if you don't write the global var, what will happen is that you will create a local global var. And if you do specify the global here, what will happen is that you are writing A plus B into the global var. Okay, now your question about the lists, it's the same. You
Instead of global var, it's the values inside, and then they work out and they will fit to.
let's see. Global LST equals 1, 2, 3, right? Now, I can read from it, I think. For example, doing print global LST, right? Now, to write from it, I don't think I can write. I cannot do LST dot, global LST dot append. I'm not sure I can do this. You can? It works? Okay, well, I can try it from here. So, Roberto, well, line 5. Diga. Não é. Ah, sim, tem razão. Ok. Estive no line, sim. Yeah, I need to call these functions. Não, elas já fazem. Não, eu só quero saber se ali o global list. Eu posso fazer o print do global list. Bem. Yeah, it works. Yeah, okay. Yeah, yeah. Sim. Tem razão. O Miguel tem razão. Parecemos completamente honestos. Vamos fazer assim. Não atualizou. Não. Portanto, o que você fez aqui foi criar, provavelmente. Eu não sei o que é que ele fez, mas não atualizou, não. Ah, sorry. Tem razão. Vai atualizar. Atualiza. Yeah. Tem razão. Funciona e de certeza que é por causa realmente das listas serem mutáveis. Ok, tem razão. Eu não costumo usar variáveis globais, não costuma ser essa a minha solução. Ok. Está esclarecido então, não está? Okay, so let's go back, end of parentheses, and we go back to this global dog named Delilah that we are defining. And now let's see if it works, because we didn't see if it works yet. So how can we test it? Well, like we did before, we just have to run our service, publisher service. Right now it's publishing the Delilah, and now we just do a raw service call. Let's change it to Bobby. So I don't think it works still. There is something wrong here because it didn't change. It said, strange. Yeah, it says there, received request to set the dog name to Bobby, but it didn't work because it continues to publish Delilah. So anyone can tell me what's missing? I know what's missing, but anyone can tell me? Well, I'm actually updating properly the dog underscore name variable, but I'm not using it anymore. So in this while loop, I'm not using the dog.name variable anymore. So I would have to do this inside the loop. Right? Otherwise, it wouldn't change. So if I do this, okay, now the name is Bobby that is being published, which makes sense, okay? However, this is not a very good way of doing it. Okay, it works, that's great. It works, that's great, but there is a better way, and I told you about it before, which is using the func tool, the partial from the func tools. So import, from func tools, import partial. So we are going to import the partial from the func tools, and forget about this dog name. Forget about this dog name. Let's just call it Delilah here. And now our dog variable is inside the main again, and we don't have global variables. So let's take this global away. Also here. But we are again with the same problem, which is how can we access from the service request callback function, how can we access the dog variable which is inside the main? Well, we can do something similar to what you said, which is we can put here a dog argument. So if every time we call the service callback, we will also be able to put there the dog, then it would work, no problem, because we would change the dog. However, we are not the ones that call this service request callback, the ROS code does. But the ROS code will only need to call the ROS service request callback, this function, with this argument, not with both, but just with the first argument. So we use the partial to derive a smaller version of the function where the dog is already defined. I've told you about this before. We would have to do this partial service request callback, where I want my dog argument to be predefined as being the dog variable here. So dog equals blah, blah, blah refers to this dog argument, and dog in green refers to the variable dog which exists in the main. Não. Não. Acho que não. Há combinações que não funcionam, sim. Você não pode, por exemplo, pôr uma named variable e depois uma proposição a seguir. Mas neste caso, a named está à frente, não funciona. Normalmente põe sempre as named à frente, à direita. So I think that works. Let's try. No, not yet, because now we need to change our dog. So now we don't have to create a new variable called dog underscore name, because that's confusing. We actually access the dog structure. Therefore, we can set its name like this, right? Dog dot name, request new name. I think this will work. Let's try it. So we are going line 57. Where is it? Here. Now, if we want our dog, I will change directly. So I think it works like this. Okay. Now we are publishing the name Delilah. We are going to change the name to Bobby the Great. And now we are publishing Bobby the Great, right? So it works. And that's it for exercise 5. Any questions? Well, I know what you are feeling. You are saying, oh, this is a lot of stuff, and I can understand what he's doing, but if I try it myself, it will be hard. Right, that's why you need to spend a lot of hours at home working on it, okay? So if you take a lot of time, if you spend a lot of time, that's normal. That's what is expected. Actually, I would like you to take into consideration that whenever you see me doing stuff in 1 minute, I don't really take 1 minute. I take 1 minute plus 15 years of my past where I've worked on this stuff. Okay, so this takes a long time. It's normal. Let's go into exercise, the next one. So now we go into the part 09. So we're going to do name remapping. So another very nice feature of ROS is that it allows for a lot of code reusage. What does it mean to reuse code? It means that you write your code once, and then you can use it in multiple variants of the same problem. And so ROS allows the nodes to be reconfigured quite easily and to a large extent. And this is very interesting. That's what we are doing in exercise 1. So for exercise 1, I'm not going to create a new package because that takes time and that's not the purpose here. So I'm just going to show you how to do the exercise 1 of part 9 directly here, okay? So what we want to do is to change the name of a node by doing something like this, underscore name my node. And we also want to change the name of the topic. Well, to change the name of the topic, we did it already because we have here the argument parser minus minus topic. So if we want to change the topic from chatter to conversation, we can do it by changing it by doing minus minus topic, blah, blah, blah. However, we had to write code specifically for this purpose, which made our published service node much, well, not much, but a bit more complex. ROS does it automatically for the nodes. It will take into consideration the following. It will define, it will use the definition of a name. What is a name in ROS? So a name is something that you use to give a name to some entities. These entities can be topic names, node names, service names, parameter names. So you have names for many things in ROS, and all these things that have names can be remapped to some other name easily, and you will see how. So first, the names of ROS will collide with the argument parser. So I'm just going to take away the argument parser. So what if we do not have all this? If we do not have all this, then when we go here into the publisher, we don't know which topic to publish on. Let's just say, let's publish on the chatter because that was the default. For the service, let's also use the default set dog name. For the frequency, let's use 1 because we cannot configure it anymore. And that's it, okay? So now we go back to stage 1 or stage 0 rather, because we don't have any code to configure our node, but this node will always work in the same way, meaning it will always publish to the chatter, it will always use the service set dog name, it will always work at 1 Hertz, so it's not configurable. Well, the fact is that it is because it's a ROS node. So how can we do reconfiguration of this? We use the remapping. How so? When I run my node here, for example, this one, ROS run, PSR, blah, 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 I can actually remap, for example, the chatter into the conversation. So if I run this, I'm actually remapping, and if I show you what's happening here, I have here my publisher publishing on the topic conversation, and my 2 subscribers trying to subscribe the chatter which nobody is publishing. So the key point here is that I've done this without adding a single code line. I just write their chatter and then I remap the chatter to something else. This is very interesting from the point of view of reusing the code. Of course, there are code lines for this, but they are included in the libraries of ROS whenever we do a ROS by init node. They already do this kind of stuff, okay? I can change the chatter, which is a topic type, but I can also, topic name, sorry, but I can also change, for example, the name of the node. I can do it like this. So, __ name, 2 points equal, my node. Okay? So now, I have my node publishing a conversation. And it's working fine, again, without changing a single code line. I can change anything that is a ROS name. For example, I can also change the service set dog name to set my dog name. So in this case, if I do ROS service list, you will see that I have a service called set my dog name instead of the original one set dog name. Okay. Again, I'm changing stuff. What else can I change? I forgot. Let me see. Yeah, set dog name is there already. Yeah. So the idea was that I took away a lot of code, and now the code is even simpler, and still I can reconfigure the node to run in many different ways with different names, different topics, blah, 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 blah. Now let's jump into exercise 2. So in exercise 2, we are going to discuss parameters in ROS. What are parameters? Parameters are variables which must be used by different nodes, not just by one, but they must be shared by different nodes. One example that I give here is, suppose that I want to use a specific color for printing. And I have several nodes that print, one subscriber, one publisher. So this definition of which color to use for printing will be a global parameter. And I can define the global parameter using the Ross param function. For example, here, if I do let me clear, and if I do Ross param list, I will list the current parameters, which right now are just default ones for Ross. And now I can do Ross param. What was the example about? Let me see. Yeah, the highlight text color. Yeah. I'm just going to call it color. So if I do Ross param color, Ross param set color, Ross param set / color to red, I'm actually creating a new parameter called color. I will need this dash. It can be there or not, and it will contain the value red. So for example, if now I do Ross param list, I will have a new parameter called color there. And if I try to see its value, Ross param get color, it's red. Okay. So right now I'm accessing the parameter using the command line, writing and reading from it, but we can access it also from our own code as an API. How do we do it? Well, we do it like this. So you can see here that we can get a parameter like this quite easily. And we write this in our Python code. For example, let's say here that after we create the service, we are going to get the color for printing, right? So we are going to create a variable called color, which will be filled with the value of the parameter color, right? Now, when we start printing, for example, here, we do publishing. Let's say publishing is always back. So here I would have to say something like for.blue plus str plus style dot preset all. You know what this means? This is from Colorama, so I have to include it. You've seen this before. From Colorama import. Sorry. For and style. Yeah. Okay, got it. Now, what I will do here is I will always put the dog printing in blue. So if I run this, the dog part is blue, right? Now, I don't want the dog part to be always blue. I want the dog part text, the text of the dog to be of the color defined by the parameter. Now, the parameter right now is red. So I would have to write something like this for, and here I would have to put somehow the value of the parameter, right? Something like this. So this is done by using a function called getAttribute. The function getAttribute will pick up an object, the object is a for, and we'll get a field of that object, which it calls an attribute. And the field in this case is whatever is in variable color. Something's wrong here. I don't know why it's still red. Get attribute. What's wrong? Publishing. No, it's okay. Needed some time to think about things. Okay, so now I'm being able to define the color of the text which I'm using to print the text. That's it. So, for example, if I run it now, it will be red, right? Now, if I change the color to yellow and I put my parameter with yellow, it's still red because it isn't updated, right? So if I run it again from the start, it's yellow. So Enrique, how can I change this in order for whenever the parameter changes, immediately I will have my node printing in a different color?
Line 45 can go under the one.
Of course, great.
I have a question. What would happen if you wrote this to the wrong name of the color?
Fresh.
Good question. Good question. Let's go. Wait a moment, please. So let's first try your solution. Again, here's my server. Now let's start writing in magenta. Okay, it's magenta. Now let's start writing in red. Yeah, it's working. It changes color immediately.
He said it in a way that it seemed like it wouldn't work.
No, it works. But I never trust. So the message is don't ever trust yourselves or the code. You have to test it. So I went and tested. How so? How would you do it? Mm-hmm.
I don't know how to do this.
It has to be, well, it depends on whoever wrote this function, what it meant to be the first and the second argument. That's so whoever defined the get attribute function defined that the first argument is the object and the second is the attribute in which you are on which you are going to search the object. Yes, exactly. So, we're not what? No, we're just getting. There is a set attribute, yeah. No, so that's the set attribute. For that, you give the object and then you give, and I think it adds a new. I'm not sure if it works. I don't think I've ever used it in Python. In MATLAB, it works, but in Python, it's a bit trickier. In any case, although, yeah, I use it, it works also. I got lost now. No problem. It's your accent. So I got lost because this is already working, right? So we have already changed a global parameter and it's working, no problem. So let's get into the next place. Actually, we can do also the global parameter for the subscriber. How would I do the global parameter for the subscriber? The global parameter of the caller. What do I have to do on the right-hand side? Yeah, I want my subscriber here on the right also to print with color. How can I do it?
You also need a one loop to the color that you
Do what?
I don't know.
Yeah, what Miguel's saying makes sense. Instead of continuously, periodically asking, tell me the color, tell me the color, tell me the color, you only you only read again the parameter of the color whenever you need it. When do you need it? When you are going to print because you received the message. So only here you need to read it again, right? Makes sense?
Yeah.
So here I'm going to read the color. Oops, sorry.
Yeah, because the callback is called
Whenever you receive a message.
Yeah.
Here it is now. I received the message. I received. Let's put it here with the get attribute to this 4, color plus there is a plus is missing here. No, of course I'm missing the 4. Okay. Okay, I think all that's missing is the resetting style, not reset all. Okay. Let's try it. So of course we need to reinitialize the subscriber. And here, remember I said my shutter was conversation, so I need to say my shutter is conversation also here. Oh, did I take away the, no, I have to take this away. Okay. So now, yes, shutter, 2.simple conversation. Okay, now it's receiving. Now everyone do it in yellow, for example, or blue. Okay, now both of them change to blue. Makes sense.
You are making the colors bleed, like, get out.
I'm updating the color with the get.
Inside as well, like,
I'm not.
so how do you
I changed color because I'm not updating the color. I'm just getting the value of the color from the object for. Makes sense? And then I'm using it to change the color of the print. Makes sense?
The question a few minutes ago about the wrong name of the column. What would that mean?
All right. Sorry. So this is what happens. If I change to a color that does not exist, it fails and crashes. But oddly enough, it only crashes on the publisher side, not on the client's, not on the subscriber side. Well, first let's try to understand why it crashes on the publisher side. The line where it crashes is line 54. It says, oh, 4 does not have blue 3234. So it crashes here, right? I think it was 52.
No, it was on the 54th line.
54.
So they get that you're good.
Yeah, right, here, right.
Because it didn't send the message, the other one didn't try to read.
Not really send them, no, because the value color print color, well, you don't need it because the variable color contains the value blue 3234. So what happens if I write here for blue 3234? It says, oh, this field does not exist in this class. Okay, so that's why it's complaining. So if there is a wrong color there will be a problem for sure. There is a. Espero bem que seja em Linux. There is another problem that can occur, which is the following. What if the parameter color does not exist? So let me Ross param delete color. So now it does not exist, period. And if I run my node, it says, oh, I can't do that. And now it says in a different place. It says on line 52. It says here, you're trying to read the color, but I can't read it because it doesn't exist. You can use as a second argument the default value. So for example, if you do this, if that parameter does not exist, you will use the red color. Okay, so it's nice because you can read the parameter, and if it doesn't work, you can just default to something. Okay, the only thing left to explain was the following. If I'm running this, yeah, no, of course, now I need the color argument here. Blue, for example. Now, if both are running, and I change my color to something that does not exist, non-existent, only the server, publisher-server will crash and not the client, the subscriber. Anyone can tell me why? Go ahead.
This would be because the publisher never sent the message, it never
Exactly.
the comment.
Exactly. So the publisher crashes, and it crashes, and because it crashes, it doesn't send the message. So if it doesn't send the message, the subscriber will never try to get the color and use it for printing. So that's why it doesn't crash. Okay, that's it. Let's continue. So we can also do private parameters in ROS. For example, let's define a private parameter just to change the frequency of publication. So a private parameter, you define it like this. You just use the tilde like this to define a private parameter. Let me create here a private parameter called frequency. Frequency, oops. And here I put my frequency. Now I can default to 1 Hertz, for example. So if I run this without adding the parameter, sorry, not the subscriber, the publisher. Yeah, like this. So if I run this without adding the frequency, it's slow, it's 1 Hertz by default. But if I say something like this, my private parameter, I need to start with an underscore because it's private. Frequency is going to be 100. That means that we are going to run this, the while loop at 100 hertz. It's very fast. Let's see what private parameters do. These are parameters just for a single node. I think they appear here, ROS param. I'm not sure. Yeah, so you see, this is a private parameter because it was pushed into the node's namespace. What does it mean? It means that the name of the parameter is not just frequency, it's frequency preceded by the name of the node. So dash my node, that's the name of the node, dash frequency, there it is. That's good if you want to, for example, have a different frequency for each publisher. For example, suppose that I have a new publisher here, which I also want to run, but it's going to be called my node, my second node. Okay, I can run this at a frequency of 10, and it will be slower. So the one on the top is much faster than the one on the bottom, because I have a different frequency parameter for each. I have the frequency of my node, which is 100. And the frequency of my second node, which is 10. Actually, you don't have to trust me. I can show you. ROS param, my node, ROS param get, sorry. My node frequency, that's 100. My second node, that's 10, right? Okay, so private parameters are good because they are pushed into the node's namespace, and you can have several parameters hanging over your node, or depending on your node. That's for the private parameter. What else? Parameter files. So sometimes you have to write a lot of parameters, and it's not practical to have to do all this in the terminal, as I'm doing right now, just to show you how you can do it. When systems become more complex, you typically want to have a file containing several parameters, which you can load. So I'm just going to create a file like this. These files for the parameters are usually placed by convention in a folder called params. And the files are YAML files. So let me create here a params.yaml. Okay. And here I just put my parameters color. Oops, sorry. Color. 2 points. Let's start with blue, for example. What else? Some other variable A will have value 4, something like this. So you can just put any parameters you want here. You could put a lot of them. In this case, let's just use 2. So how do you load these parameters? Well, let's restart the system. So we kill ROS core, that means the system is restarted. That means we do not have any kind of parameters in the list, except for the standard ones. Okay, just the ones created by ROS core. Now, we can load the parameters from the file by doing this. So I'm going to the place of the parameters, and now I do a ROS param load params.yaml. If I load my file containing the parameters, ROS param list, now I have the A and the color parameters, which were the 2 ones in the file. Okay, so very easy to load parameters from a file. So ROS launch files. Now we get to the ROS launch files. So I'm going to do an example, and then from here on onward, you will do it yourselves. So for the ROS launch files, the problem that they are trying to solve is the following. I'm not sure how you feel, but I would suspect that you feel overwhelmed by so many nodes being launched at the same time. This is a lot of stuff, and it's hard to keep track of what's running on this terminal and what's running on that terminal, and so on and so forth. And you may say that my windows are very confusing, but typically, if this is a student and not me doing it, it would be something like this. Okay, this is node 1. Okay, now this is node 2, now this is node 3, now this is node 4. And then typically you will do something like this. Okay, this is 1, 2, 3, and 4. And it's what I'm saying is that it may look complicated from the way I show you, but if it's the typical student doing it, it's far more complex. Okay, you do not have this way of trying to simplify things, of putting one thing on one side, the other thing on the other. Okay. So yes, this gets very complex. How can we somehow reduce the complexity in order to still be able to program? Well, you can use launch files. What are launch files? They are scripts in which we can define what must be launched automatically. So we can have, instead of 6 or 7 terminals, we can have a single one where we launch a constellation of nodes, not just one. We can launch nodes and we can do additional stuff. I will show you how. So if we want to create a launch file, what you must do to start is to create a launch folder. So let's create a launch folder. And inside we create a launch file. The name of the launch file is, well, it's discretionary. You can decide on your own. Typically, I also use a convention, which is to call it bringup.launch whenever it launches everything in the system. Bring up. So now we have to see, we have to write something here in our launch file. This is not Python code, this is XML code, and we have to look at for the syntax. So ROS launch file example. Okay, so I think we have an example here somewhere. Okay, this is a very simple example. So we start by defining the launch node, the launch upper level. This is just because this is an XML, so this is the launch file, so it starts with launch. Then we can put here stuff to launch several nodes. So for example, let's launch the first node. Let's comment this on XML. And now the parallel is the following. Whenever we want to run something here, look at what we do. We do ROS run, that's the first part. Let me just clear this part here. We do ROS run, well, better. All this stuff is not needed for now. Okay, now yes. So whenever we do this, we are creating the following. We are first doing ROS run, that's the command. Then we are defining the package. This is the ROS package. Then we are defining the file that we want to run, or the script. And finally, we are defining the name of the ROS node. Right? So there is a direct parallel to what we do in the launch file. First the package, then the file, then the ROS node name. And we can go up here and see. Well, that's why I don't like this here. I prefer it there. And you can see that we are going to launch a node from a given package. In our case, PSR 22 P1 part 08 exercise 5. The type is it's here, publisher service .py. That's the type. And the name, I was calling it my node. Okay, so it's a direct parallel. You can just specify which file you want to launch on which ROS package with which name. That's it. So this is launching my node already. So one thing about ROS launch is that you can use it to reboot the system from scratch every time you run it. So you remember that I was always launching here ROS core manually. When using ROS launches, I don't need it. So I can just do the following. So instead of having 4 terminals, let's just have one. And in this one terminal, I'm going to do ROS launch, the name of my package, PSR 22 P1 part 08x5, and now the bringup.launch. So what will happen now is that the launch file launched a constellation of nodes right now with a single node. So right now ROS is running with a single my node. Of course, I can make this more complex, but easily. Now I don't have to open a new terminal, yada, yada, yada. I can just do it like this. You want a new publisher? No problem. Let's run a new publisher called my node conversation. Okay. So if I shut it all down and bring it back up, right now we have 2 nodes publishing on Shutter. And now let's launch a couple of subscribers. Okay, so for the subscribers, the different part is that they are not called using this. Rather, the script is called subscriber.py, right? And let's call it my subscriber 1 and 2. Subscriber 1, and here let's do the 2. Okay. So now if I run it again and refresh, you can see that I have my node conversation, both publishing to Shutter, and then 2 subscribers listening to the Shutter. So this is very easy to do with the launch file. You can it's very flexible and easy to call a new node, call a lot of nodes, etc. You can also configure these nodes in the following way. For example, suppose that you want this, I'm not sure what's happening here. I know. Okay, look, the nodes had a problem because we don't have the parameter caller. That's one problem. So one thing we could do is try to load the caller parameters. You remember we did ROS param, load, blah, blah, blah. But that's another thing we have to do in another terminal. That's not what we are looking for. What we are looking for is to do this also in the launch file. So in the launch file, we can do the param, not the param, sorry, the ROS param, I think. ROS param load here. Look. Copy. So let's load a parameter like this. ROS param load. Now we have to say where the file containing the parameters is. Now our file containing the parameters is somewhere very complex. So if I go there, actually we are there already. So PWD, this is the place. So I could come here, copy. Oops, sorry. I could come here, copy paste this, and put it here. I could do that. But this doesn't make sense because the ROS code that I develop here should run in someone else's computer. So if I go to Miguel's computer, for sure, his path onto this package is not the same as mine. For example, for the simple case that he will not have home mic, he will have home something else. Don't tell me you also use mic. Okay, so we are not looking at defining the whole path here. ROS also has a functionality that helps us a lot, which is if we do this find ROS parameter, find blah, 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 this part will actually search for the path of the ROS package that we want. For example, if I do ROS find and the name of my package, PSR 22 P1 part 08 EX5, that's the name of my package. It's this one here. What will happen is that ROS will automatically replace this between parentheses by the actual path of my package. So it will find my package path, okay? So we don't define hard paths, we define paths relative to packages. And if I'm in package part 08, that means I'm here. Then I need to go into the params folder, and only then I will have a params.yaml file. So I need to go into my params.folder, and only then I will have my params.yaml file. That's it. So this loads the packages, this loads the parameters contained This loads the parameters contained in my params.yaml file, which in particular have the caller parameter, which is needed to run the nodes and not result in these errors. So if I do the ROS launch again, now yes, we don't have crashes because they are not missing the caller. The architecture is more or less the same. Well, it's actually the same. And don't you notice something strange? You don't see any of the prints that the nodes had before. So if you want to see the prints of the nodes, for example, I want to see the prints of the nodes, my node, I have to add here something which is output screen. Okay. If I do this, what I will see in this terminal is the output of that particular node. Okay, so it's printing in blue, as you can see. I could do this for several nodes. For example, let's see what the subscribers are saying. At least one of them. Okay, so now here the prints are from the publisher and the subscriber. So you can see there it says publishing blah blah blah. I received blah blah blah. Okay. So that means the ROS launch file is very flexible. You can configure a lot of stuff. Now, something else that you can configure is doing the remapping. Suppose that this my node conversation is not supposed to publish on a topic chatter. So this is not supposed to happen. I would actually like it to publish on a different topic called conversation. Right? So how can we do that? We can remap the chatter to conversation. And we can do it in the launch file as well. We do it like this. So first we open node. So this is just to say that this part refers to my node conversation. And here I'm going to do a remapping. Where is my remap? Remap, not here. Remap, here. So that's how you do a remap. So notice the remap is inside the node because it's a remap that refers to the chatter topic of that node in particular. So instead of chatter, this guy will have the topic conversation. Let's run it. Okay, so if you take a look at now you can see that my node conversation is actually publishing on a different topic, which means you can use the launch file to launch a combination of nodes, a very complex one. You can use the launch file to load parameters, to define the names of the nodes, to change the names of the topics, and so on and so forth. You can do everything in a ROS launch file. Okay, so I know this has been a lot of information since this morning. So now I'm going to stop. I continue next week. What do I need you to try to do? If you haven't done so far the ROS tutorials, well, you're kind of screwed already, but you should try to do them. I'm joking. You should try to do them anyway. But what I'm saying is, try to do exercise 5. Okay, so you've learned enough to try to do the exercise 5. The goal here is that you launch a constellation of nodes with specific messages passed from one place to the other, as is defined in this graph. Okay, so try to do this in the 30 minutes that are remaining in this class, and next week I ask you for the solution for this. Okay. Okay, I'm going to stop now because I know it's a lot of information, and now I help you whatever you need. So if you don't have ROS installed yet, or whatever problem you have before, tell me, and I try to help. Okay. ROS2 passed from XML to Python, the launch files. Yeah, although it still supports launch files in XML, but they are not so used. Actually, I think it's something I'm going to miss when I go to ROS2, because I've worked a lot with XMLs. Tenho certeza que tem o Ubuntu 20.04. Vamos ver aqui. How to check. Poxa. Consegue fazer o LSP release -A?
Over here, if you lost the video, One. Here. Yes. Thank you. Now, away from there, this is the problem. So, what was the start? We need to try to compile the rules. How is the Let's compile the rules. It's finished and compile the we created the next problem. If you want to now that you have this, how can you run the code? For example, here is the problem. It's not small. It's something. You can't see it in the bottom. The raw material. You have to fix we must configure them for this is even when we want to meter, and here we must define how loss should so So we have to do this like so really you know, in these files, so we have it run very well, so that I go through this we start from the we go into the fast. Second thing, you have to make sure that the last page. Export the. Yeah, so inside this. And so. Export. The leave of you have to work space. Stopping lines, but never use it's not part of speed. For PSR, he said, oh, you have the very already. They already recognized. Now you can choose for another one. So then what I did then on a particular goal. The same place. And now. And now we can get this. No. Now we're running in. Gina, how's it going? Are you wishful that you never thought of coming to this course? Yeah. So. Then you can spend a week in restart, so you can move on. Yeah. Okay.
E a gente está a usar para a administração do módulo do SI.
ACML. Acho que é IMC.
É impossível. Assim é isso, é isso. Estou a ter alguma sugestão de outra área. Nós vimos e deixámos que acontecia. Nós temos uma equipe de São Paulo, de scan, que hoje era uma. Vamos usar.
Depois o scanning pelo vai não é um 2D?
É usar em lá.
É só um plano, não é?
Sim, sim, estamos a usar em lá. A programação deve fazer aqui nos das férias e o processamento não. O processamento tinha que ser ao mínimo.
Vocês gostam de desafios.
A ideia era mesmo provar que aquilo lá vai ser feito com o competitivo. Neste momento temos um PSR para o processamento da câmara.
Ok?
E aquilo apesar de dar, era preciso de um mapa ajustado muitos parâmetros e algumas complicações.
Eu diria que há outras